Welcome to Game Changers Silicon Valley, a show about today's innovations that may be the game changers of tomorrow. We have seen remarkable breakthroughs in the treatment of infectious diseases during the past 60 years, including smallpox, chickenpox, and a wide range of bacterial and viral disease. One major area of challenge has been the treatment of degenerative disease, which are based on degenerative cell changes causing deterioration of body tissues or organs over time, whether due to normal bodily wear, lifestyle choices, or areas such as smoking, exercise, and eating habits. My name is Jim Conner, and I'm pleased to have two guests who can provide insights into the research and work being done in this area of degenerative disease. My guests are Bob Molinari, founder and CEO of Retrotope, and Harry Saal, a well-known angel investor. Bob and Harry, welcome to the show. Let's talk about this area of degenerative disease that is causing changes and problems in our society.
Thank you, Jim, and thank you for having us on the show. As you know, as we age, we're seeing a whole class of diseases, typically called degenerative diseases, that are taking hold and are unable to be treated well. Things like Alzheimer's, Parkinson's, diabetes, diabetic retinopathies, and the like. And what these have in common is that they're sort of a side effect of the oxygen, the very oxygen we breathe. Over time, there's a paradox. And you'll see that without oxygen, we die in about 3 minutes. However, when we decided we wanted to be more than single-cell organisms, we found out that if we burned oxygen, we could get a lot of energy out of that and start differentiating our tissues. And that really was what made the difference, and it came at a price. And that price is that over time, that oxygen starts to cause all kinds of oxidation products in the body that cause degradation. And it takes a long time.
Is this a toxic effect of oxygen?
It is a toxic effect of oxygen. And what we like to say is, we all age over time and rust to death. It's just not metal rust, it's cellular rust. And if the slope happens to be very steep, we would call it a disease. If the slope happens to be very slow, maybe it's just normal aging. And we think it's all a continuum.
I see. So it seems to suggest that by doing research and finding the processes that are contributing, and let me make an assumption here, contributing to this degeneration or breakdown in cells, this may be a major contributing cause to the disease that we see?
That's absolutely correct. And what we're seeing is the very first step of that happens in the form of fatty acids on the inner surface of the mitochondria that start getting degraded.
Let me ask you a quick question. I just want to, for my purpose too, in the audience, how do you explain mitochondria? I know it's part of the cell, but I don't know really what it does.
So the mitochondria is the energy factory of the cell. It basically takes in, it's an organelle within the cell, and there's many of them per cell, and it takes the oxygen that we breathe into the cell, and it actually burns the oxygen, creating ATP from ADP, and that's the source of energy in the cell, if anybody took biology out there. Okay. But that's what gets, and that's burning of oxygen to get energy.
Right.
Fatty acids are fairly unstable and degrade all the time and are turned over. But on the inner surface of the mitochondria, if that process gets out of control, it's very hard to stop it, because it's a fatty acid area that's sort of oil soluble, not water soluble. Antioxidants can't get in there. And once it gets out of control, that particular organelle, the mitochondria, also is responsible for the generation of energy for the cell. And as the cell starts to lose its energetics, it begins to suffer and starts to fail and die.
Great. So Harry, you've got a very deep background, one that, as we said, you could consume 20 minutes telling us about your accomplishments. I'll give you we'll ask for the short version and ask, how did you get involved in Retrotope?
Well, I've been involved in many startups in the Valley.
Yeah.
I've been involved in computer science research. I was involved in the creation of some of the very first computer networking companies and computer network diagnostic companies. I've worked in other areas in brain science and food distribution. But right now I'm involved with what is certainly the company that is promising to be the biggest, let me call it game changer, appropriate on this show, that I've heard about. And compared to computer networks, compared to PCs, a Retrotope has the opportunity to really change the way we look at diseases. It's a new kind of compound. It's a new drug. I learned about it from a friend of mine, a National Academy of Sciences fellow, who was my college roommate over 50 years ago. And he, along with Bob and a third scientist, were the co-founders of Retrotope. And they came up with this incredible new approach to these neurodegenerative diseases.
So let me pick up there. I guess it begs the question, what is that new approach?
Yes,
and
I was going to ask that.
We should probably delve in there a bit. What we found out is that membranes that have this susceptible fat in them have that fat there for a reason. The polyunsaturated fats that you have to eat every day as omega-3 and omega-6 fats exist for a reason, and that is they go into these membrane spaces and they allow the membranes to be fluid and move around and have proteins lodge in them and things pass through them. And this is the part that gets difficult because they're so active in that space. They're critical. But the very nature of their structure means they also are susceptible to oxidation. So what Retrotope did is recognize that this was an important factor in the energetics of the cell and the health of the cell. And it doesn't really matter whether it's a retinal cell, a neural cell, or another type of cell. And that if we could go in and stabilize those fats without really changing anything else about their function, we could potentially have a major impact on disease. And the first way we sort of got the hint of this is many of the diseases we all know about, Alzheimer's, Parkinson's, diabetes, retinopathies, the diseases of old age, if you will. There's a marker in those cells of this type of damage, and the marker are lipid degradation products. So we backed that up, found out which bonds we needed to stabilize, and did nothing else to those fats.
How far has this research gone to being proven?
Well, the company has really been incredible. It was founded about 7 years ago, when this was literally a concept out of the blue. And since then, the company's raised money through a series of angel-financed rounds. And for the first 6 or so years of the life of the company, it spent its efforts, its finances, on manufacturing these compounds, these special, what are called isotopic versions of these omega-3 and omega-6 oils, and then proceeded to work with scientists all around the world, in universities and labs, in the U.S. government's National Institute of Aging, for example, and other places, supplying compound, helping to define experiments which were then done and published. So at this point, there's been a huge array of results published on the effect of these compounds on cells, cell tissues, human cells and tissues, on animal models, and so on. And the company now is on the cusp, for the first time, approximately a month from now, of treating and dosing the first human patients with this new compound.
What kind of dose is it? Is it topical on the skin? Is it an injection? Is it a pill?
The form factor is exactly like a fish oil pill. These are omega-6 fats, just like the omega-3 fats. They can be put into something that looks, feels, and acts like a fish oil pill, about the same size. Unfortunately, it's quite big. But people take similar kinds of things without the magic chemical change that makes them stabilized as supplements all the time. That said, this is a drug. We're making a chemical change in these things that creates a mechanism of action.
Okay, so this goes into the stomach, down through the gut, gets absorbed in the bloodstream, if I understand that process correctly. And once in the bloodstream, gets distributed to the body's tissues, is that correct? And there it has this magical effect?
So the perfect thing here is the fat that we make, because we only change the isotope of certain bonds, certain atoms within it. The atoms are themselves the same. What we find is it is a perfect mimetic. So it goes everywhere that fat normally goes, which is exactly what you want the drug to do, because now you're building up fortified, if you will, fireproof forms of cells against the disease.
So you're using the body's mechanisms, the natural mechanisms of the body to distribute this throughout your fat areas.
Right,
Completely.
and we've done those experiments, and the normal fats and we call them the heavy fats go everywhere the normal ones do.
Yeah.
In fact,
And they're processed by the body, but at least in the animal model so far, and we're going to check to see whether or not that's the case for humans. They're processed identically. That is to say that the normal enzymatic reactions that the body does to take these fats and create other versions of them that go to your brain and other organs appears to be 100% normal, except for oxidation. It's not subject to being burned by oxidative stress.
And that's a plus. That's a big plus.
That's exactly what we want to do. It's
Yeah.
very, very targeted at resisting that one component, and all other ways it's quite normal and standard.
so our first clinical trial, so the data that says this all works is in some ways quite stunning. We've been able to take mice and give them a chemically induced form of Parkinson's, and typically those mice lose the dopamine in their brain very rapidly. You dose them for 12 days with our drug orally, and they have 2.5 times the dopamine level. This is going now throughout all of these diseases. We have Alzheimer's data, we have data in other types of orphan degenerative diseases that are well established. We have data in retinopathies. And the difference, what makes this game changing, is the models of these diseases all used to be silos, very vertical and very deep, and you studied that disease only. What we're finding is there are toxins that develop in all of these different diseases. In Alzheimer's, it's beta amyloid. In Parkinson's, it's synuclein. In Friedreich's ataxia, it's free iron. And those things are no longer toxic to the cell when the patient is taking our drug.
How much money, I'll ask you, Harry, has this taken to get the company this far?
Company has raised approximately $15 million to date. This is entirely from angel investors, as I said. One needs to have typically a pharma partner to work with, and we're developing those relationships now. And the company has been, as I said, financed so far from angels here in the Valley, throughout the United States, and that's been able to power our first human trials that are about to begin.
That's wonderful.
And if you think about all these diseases, they typically have to rely on the disease expertise in the field to sort of vet whether these highly risky bets are worth taking. And what we do is we transcend all of that. We're basically saying all of those things that people worked on for years as, quote, causes of diseases are really triggers of lipid peroxidation. And a different mechanism, and it's very hard for them to vet this kind of thing.
You found a deeper level of commonality among all these expressions of disease.
I'm going to write that down.
A deeper level of commonality. You got it. Okay, great. What should we see next? What's next for you then?
Well, what we're really excited to be looking forward to is our first human trials. And we filed with the FDA about 2 weeks ago, and we're in a period when they're reviewing our application, and we hope it will go right through, and they will allow us to be in patients in about the next month.
In the next month?
Yep.
This is very exciting. I can't imagine. I mean, everybody's going to be looking for these results, whatever you get. I mean, it's going to be tremendously exciting.
We'll be happy to come back, Jim, and let you know how well it went.
I'm going to invite you back, but for the moment, I want to let both of you give your contact information for the company, because I am certain that any number of people are going to be getting online and finding out more about where the company stands and your discoveries.
Our website is www.retrotope.com, and you can get all the further information.
Is there an email that, like info@Retrotope or something like that?
Just email me. It's bob@Retrotope.
Bob@Retrotope. Harry, you're an involved person, so is there a contact relative to the company's operation that you would want to give?
I'm available anytime. You can reach me as harry@retrotope.com.
I want to thank you both. Really, this has been a delightful issue, very informative, and I'm very excited for you, Bob. This is I know you've worked hard and over the years to do this and had a lot of fortitude and perseverance. And Harry, I'm glad to see that a guy with your accomplishments believes in what Bob's doing and is willing to put your money behind it and your commitment and your resources. So my compliments and congratulations to both of you for this great process and a great success so far.
Thank you.
Thank you, Jim.
Thank you. This is Jim Connor. I'd like to thank you for joining us for this week's episode of Game Changers Silicon Valley. Each week we'll address an area of innovation that may emerge as a game changer of tomorrow. We look forward to your continued interest and participation in the upcoming shows. Good night now.